Hi everyone. Today is a dilations review day, so you get an opportunity to practice some of the things that we have been talking about in class over the last few days. So the first thing to get us started is to kind of review, where do we see dilations in the real world and the world around us? So here are just some examples of where dilations and knowing about dilations can be useful in the real world in a workforce. So the first example here is when you need to enlarge a picture from a wallet size to a wall hanging size. You can use a dilation. When you have all your different pictures and picture frames, you have your different sizes. Well, you want to make sure everything increases by a scale factor so you don't have people looking weird or different. So picture taking is a huge example of dilations being used. You can also see in other artwork here, not just in pictures, but you can also see in other kinds of sculptures where the dilations come into play. Example 2. Are you in a normal view of a scene on a camera? When you zoom in to see more of the picture, you're using a dilation to do this. So here below is an example of a bunny, and you can see how it increases, and you can kind of see the eye as it keeps going. So a dilation could be just zooming in on something. Again, you're not changing the shape, you're just making it bigger or smaller. So if you're interested in photography, you would have to know about dilations. Another area would be criminal investigators, especially on television. You use dilation to see larger versions. They'll use that to look through evidence at crime scenes, such as fingerprints, using that to enlarge to see all of the scanning of the photos and all the imprints to gather information. So if you ever watch that show, take a look at how they use dilations to help solve their cases. Okay. Another example is architecture. When you design a building, when architects are trying to build a building with dimensions previously made out by a model, they have to then increase that size of that dimension so they can get that building to look exactly like the model is supposed to be. So they use scale factors. If you are into any kind of designing whatsoever, usually you start with a model first, and that is all with dilations. And our last example, we talked about this one in class, is if you do anything with the eyes or in the medical field, you might have to do some enlargements. Your pupil is a perfect example of how your eye would dilate to make adjustments as to the amount of light that comes into play. Just a few examples of our dilations in the real world. Okay, so now we're going to move into just reviewing with these notes, so I'm going to go over them with you quickly, and then I'll explain the remaining activities for you today. All right, so dilations and scale factors. So as you go, make sure you're filling everything in and giving yourself a chance to pause when I tell you to pause. Try the problem on your own, see if you get the right answer, then click and check to see if your answer is correct, okay? You're going to get most out of it if you take that time to pause. So first of all, what is a dilation? A dilation is a type of transformation that changes the size of the image to create a similar image. So notice that the word similar is here. It's not congruent. Congruent means same size, same shape. And we know in a dilation, we're going to get the same shape, but we will not get different sizes. It changes size. So please make sure you're either using a highlighter or you're filling in the blanks. Okay, a scale factor. We're going to use scale factor when we do dilations. With the scale factor, then all the parts of that shape will increase by a certain amount or shrink by a certain amount. Anytime you play around with different scale factors within the same shape, you are going to get a warped shape. So then it's no longer a dilation. So a scale factor is the ratio. So a ratio is like another word for fraction, okay, of the lengths of the corresponding sides of the similar figures. So when we compare one side to the other side, we're going to see a difference, and you're going to see that as we do some of the examples. So our first is in dilations is our enlargement. When the image or the new figure is bigger than the original, bigger than original. Usually this happens when we have a scale factor that is greater than 1. So your scale factors will be 1, 2, 3, 4, 3.5, 2.75. You could throw decimals in there, but all the numbers are going to be greater than 1, and it's going to show you how much that object is going to grow. Okay, so here's an example. Use a scale factor of 3 to dilate this triangle ABC, given the lengths of these sides. So the first thing they want us to do is find the lengths of the sides of this triangle and write down the lengths here. So this would be a perfect opportunity for you to pause the video, Go ahead and try this section. You can even pause long enough to finish the entire example, then come back, hit play, and see if you did the answers correct. Okay, so so go ahead and pause it. All right, when you come back, we're going to go over the answers. All right, so the first thing we would do is find the lengths of the side. AB is right here, so that has a side length of 5. BC is right here, has a side length of 4. And CA is right here and has a side length of 3. So the first thing we do is we identify our side lengths. Now we're going to use our scale factor to get the enlarged side lengths. And how do we do that? We use multiplication to help us use from the original to get to the new. So I'm going to switch over to a pen instead. And so if my original side length was 5, feel free to pause here, if you want to try this on your own. Otherwise, if you have the answers, keep going. So 5 times the scale factor of 3, so times 3, would equal 15 centimeters. So A prime to B prime would increase to 15. Okay, B to C was 4. Increase it by the scale factor. 4 times 3 is 12 centimeters. And the last one, C to A, is 3. Multiply it by 3, and we get 9 centimeters. So that is how we would apply our scale factor to the original dimensions to get our new dimensions. And that's how big the new triangle would be if we increase this 3 times the size. Okay. In example 2, we're going to talk about reduction. So what is reduction? Reduction is when the image is smaller than the original. This happens when the scale factor is less than 1 but greater than 0. So in other words, when it's a fraction or a decimal, okay, would we see that scale factor? And most of the time, your scale factor is going to be in fraction form if it's going to be smaller. So in our example here, we are given a scale factor of 3/4. This is a scale factor we have not seen yet. So we're going to practice making sure we know how to use our fractions. Find the lengths of the sides of the shape given this scale factor. The two sides of this shape are 20. There's 3 sides that are 20 and 2 sides that are 12. So all we have to do is work with the number 20, the original, and 12. So let's start off with the side that's 20. So what we would do is we would write our 20, and we're going to multiply that by our scale factor of 3/4. It's always handy to take this 20 and put it over 1 so you can see your fractional parts. Again, don't forget to stop. Okay, if you want to try this part on your own, stop and give it a try, or watch my first one, stop it, and then try the next one on your own. The more you try on your own, the more you're going to see if you're on the right track. All right, so now multiply going across. 20 times 3 is 60. 1 times 4 is 4. And now we have 60 divided by 4. If you divide that, you would get 15. So the scale factor would go from 20 to 15, and that would be a scale factor of 3/4. All right, go ahead and try the next one. Again, pause here if you want to try the next one on your own. Keep watching if you're checking your work. So 12, this would be 12 over 1. Multiply that by my scale factor, 3/4. Multiply going across. 12 times 3 is 36. 1 times 4 is 4. And then finally I'm left with 36 divided by 4, and that equals 9. So the 12 inches, oh, I'm sorry, these should be inches, not centimeters. Get your dimensions straight, Mrs. Meyer. All right, so that is how you would apply scale factor. Scale factor is always multiplication, and don't be afraid of those fractions. Just put the whole number over 1, multiply across. You can use a calculator to help you with the division if you need it. Okay, back side. Finding scale factor, a little bit more practice. If you are given 2 shapes and need to find the scale factor, you must know which was the original and which was the new shape, or we call it the image. The original or the image, which is the new shape. Then we need to know the length of the corresponding sides so that we can get the correct ratio. So here it is. So we do image divided by original gives us our scale factor. So hopefully this is review from last year. So here's our first example. What scale factor was used to dilate WXYZ to WXYZ prime? Well, so first we determine which shape is the original and which is the image. Well, we dilated this one right here. So this is the original, and we moved to this one. So this is the image. So now that we do that, we can set up our ratio. So the side of the image is 20 feet, and the side of the original is 10 feet. So we are left with our ratio, which is just a simple division problem, and 20 divided by 10 simplifies to 2. So our scale factor would be 2. So that's another way to make sure that you can find scale factor, especially if you don't have a grid that you're counting on. You can just simply do the math. Okay. Okay, then we have one more set of problems. Again, if you just want to try all this on your own, don't forget to pause the video, try some of these problems, see how you do, and then you can always fix it if you don't have it correct. But that's how we learn. All right, so the next one. What is the scale factor? We're going to dilate triangle ABC to ABC prime. Well, here's ABC to ABC prime, so we're going this way. So again, this is the original, and this is the image. It's important to know what direction we're going into. All right, so first, this is our new shape, this is our image. So we can pick any dimension on this triangle, but we have to pick corresponding parts. So they've got to be the same. So for example, if I picked this part right here, I have to find out where that part on the triangle is over here. So obviously AB is going to be similar to A prime, B prime. So I'm going to take 15 and 5. So the image is 5, and the original was 15. Okay, so that would be my scale factor. Can I simplify this to make this a better fraction? Sure, I see a 5 and a 15. I can divide both the bottom and the top by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. Our scale factor ends up being 1/3. Because we are shrinking, so it should be a fraction if we did it correctly. Now, if you would have picked any of the other corresponding sides, let's see if I have another highlighter here. Yes, I do. All right, so let's take this last side. Let's do this side and this side. Do we end up getting the same answer? So our image was 3, and the original was 9. And I look at this, and can I simplify it? Sure, I can divide both by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So no matter what side you pick, you're going to get 3. And if we do the other one, 4 divided by 12, divide by 4, divide by 4, 1/3. So you can see no matter what corresponding side you pick, that scale factor should be the same because that's part of the dilation. All right, so please make sure that these get put someplace safe in your notes. You can use these as you take the dilation review activity, which is located in Google Classroom, as an assignment. It's going to be a Google form. You can use your notes, but you can't use a classmate. Let's see what you know right now with dilations, so I can kind of take a look and decide where we need to go from here and what kind of things we still need to cover before we continue to move on. So it's really important. Do your own work. Okay, so that way I can get the best information to help you. All right, so when you are finished with this and the activity, you can go on to the practice problems. You're going to get your pink packet today, so you can actually do the practice problems right in there. If you've already done some problems on lesson 2, you don't have to do it over again in the packet unless you want to. But remember, when we do quiz, that's where I pull the quiz questions from. If you finish with everything, you could have some freckle time for the remaining of the hour. I will be watching you on Orchestrator, so please make sure that if you are online, you are where you need to be. And have a good day. I want a good report, and I will see you tomorrow. Bye, guys.